Well, hello, everybody. I think we'll be waiting for about a couple more minutes to begin the webinar itself. It's Demi and Amit here. Amit, say hi.
Hi, hi.
And I think I will be shutting off my webcam just to be sure of the connection. So I think we'll wait until 2 more minutes from now and we'll begin the webinar itself. Okay, I think we'll begin our webinar. So first of all, thank you for Codemotion for hosting the webinar itself. It's an awesome community and it's great to be a part of it. And today we'll be speaking about monitoring big data systems done actually the simple way. And it's mostly from experience from tools and things and methods that we know from the market today. And also from experience of Amit and mine from our past and previous roles in our, like, I would say, DevOps and infrastructure career. One sec. First of all, we have arrived here to the Codemotion webinar series, and I wanted to also present the next events and conferences of Codemotion in Madrid, Milan, Berlin, and Amsterdam. For you to be able to also register, you also can enter the community page itself in codemotion.com. So again, thank you for hosting, and we really love the collaboration together with Panoramic and other webinars that we've done also with Codemotion. A bit about us. So my name is Demi Ben-Ari. As I mentioned, I'm the co-founder and VP R&D of the company called Panoramic. We're a cybersecurity company, and I will say a few words about the company also. I'm also what's called the Google Developer Expert. Basically, that means that Google certifies me that I talk a lot. So if Amit won't actually interfere me and ask questions, or at least interact with me, I can continue on talking probably all day long.
I'm
also
a
co-founder. Yeah, the good role. I'm also the co-founder of different kinds of developer communities. In the past, I was a data engineer at a company called Windward. And the previous role, I was around 8 years in the Israeli Air Force, in which I developed a missile defense system. So there I also developed an on-prem systems, etc. You can find me on Twitter also at Demi Ben-Ari. Amit, please present yourself also.
My name is Amit Oren. I'm currently a DevOps engineer at Panoramic. I'm a huge SQL advocate. So if you hear any subtext during this talk, it's mostly because of that. In my previous job, I was a big data developer and DevOps at Wingo. And before that, I was a system administrator at the Israeli Air Force.
Awesome, thank you. So because we're a cybersecurity company, there has to be a hoodie, okay, and somebody trying to hack something. So this is a lot. Our head of security research trying to do some, I would say, peaceful, malicious things. And I'll talk a bit about the agenda of the talk itself. There will be a lot of not funny jokes. Why? My wife is a software engineer also, and she saw me making this presentation, and she told me that I'm totally not a funny person. I don't care, at least I make myself laugh. We'll talk about the problem definitions and environments that we've handled in the past. We'll talk about monitoring pipeline solutions, things about metrics, data stores, dashboards, alerting. We'll summarize things, but it's important to mention that we won't be speaking about a really big problem actually in the world of monitoring, which is service discovery and monitoring on all of that. This is something that is a whole different lecture that we can speak days and days on top, and basically we don't want to open that right now. So what do we do at Panoramic? I would say the buzzword of mapping the world cyber posture, but basically we help companies to manage the cybersecurity risk that is imposed by their supply chain. If you think of it that today we're using a lot of external services practically for anything, cloud service providers, emailing services, etc., all sorts of interconnected tools for infrastructure. But not only that, we have also not our IT vendors, financial services, payroll services, law firms, accounting companies, etc. So how do you actually manage the risk of handling all of your data, which is dispersed among your vendors? So basically what we do is we look at every company and every supplier in the hacker's point of view. We give, without any need of installation, to our customers full transparency on their supply chain monitoring in general in the world of cybersecurity. We do the dynamic ratings 24/7, and we continue on monitoring all of the suppliers in the hacker's point of view. And basically, we can alert if something changed in the attack surface of any company that our customers work with and notify them. And of course, they can actually respond afterwards. So this is a really, really brief summary because this is not what we actually came to talk about. When you talk about distributed frameworks, when you say big data, you talk a lot about tools, okay? When somebody says I'm a big data engineer or I'm a big data whatever, basically he means that he has proficiency with using tools like these, which are distributed in a cloud, usually, or it might be on a large sum of infrastructure. We spoke about like Hadoop, Cassandra, all sorts of cloud service providers, Apache Spark, Mongo, and all sorts of different kinds of databases. But basically, I'll let Amit explain to us what is actually big data and what do people mean when they say, I am doing something in the world of big data.
So some questions to ask before you go and say, I'm doing big data, I have big data, is first of all, how much volume do you have? Do you have a terabyte of data? Do you have half a petabyte of data? How fast do you want your queries to go? You can put all your data in Postgres, but you won't necessarily get response in the amount of time you want to. And what's the variety? Do you have multiple sources of data that are all different and coming at you with certain velocities? So all of these together measure how big is your data. And it's important to know that if you can solve your issues with conventional solutions, your MySQLs, your Postgres, your Redises, you should probably do that, because with big data comes a lot of complexity with all the distributed systems, actually, that you want to avoid as much as possible.
I totally agree with that. So again, when we speak about big data and monitoring, etc., what are we trying to actually monitor? Because if we go back, the traditional way of doing monitoring is basically monitoring your infrastructure, right? But we can convert that to actually talking about the pyramid of information and things that we actually want to monitor in our company, okay? And not only in the infrastructure. So of course, the underlying layer is infrastructure. We want to know how our server's doing, if something is peaking, if something is picking up, and it's important. But on top of it, because of the world of what we call big data, we need to actually monitor the data itself, okay? And we go into the whole world of actually knowing what is going on with my data. And is it okay? Is it all digested and actually inputted to all of the data stores that I'm using? But not only that, the data is actually means to get something, right? We want to create some kind of product, but product usability is another thing that we want to measure. And we want to see and have transparency on top of what's going on, right? How many features and which customers or like users are using in our product. So this is also important. Of course, we're scaling down all of the telemetrics that we're getting from the infrastructure as we go up the pyramid. And the most important thing to actually measure and give transparency also to the management level is basically the business. How do you monitor the business? Okay, and we can have multiple KPIs, and we'll explain what that is afterwards. But we have key point indicators. This is the acronym, and basically we want to measure the business. Is the product that we're creating actually giving the business some benefit? Okay, and I was in one company that they have an actual dashboard that shows only one number. Okay, and this is pretty amazing to see. It's the amount of money the company makes. Okay, and it's astonishing to see. First of all, it's important that number rises always. Okay, if not, we're in a big problem. But again, it's a metric that I can actually measure and quantify, and afterwards show that and monitor it. So if I have some kind of drop in that, basically it's something to alert upon. So let's go back. Okay, what are you trying to actually monitor? Every startup company, every company that, even like a large corporation, when you start off something, some kind of project, you end up with some kind of monolith structure. Okay, you have the operation system, which will CPU, memory, disks, and other features that Amit will speak about in future slides. On top of it, of course, you have processes. You have databases, which are processes also, Java applications, application servers, web servers. On top of it, sometimes you have load balancers. They might be hardware load balancers or software load balancers. And of course, you have other kinds of applications that are interacting with us, user applications that are running, or external third-party APIs also. Awesome. You have a lot of moving parts, okay? And many times, all of these are on a single physical server or a virtual server. It really depends on if you're on the cloud or not. And of course, you need to monitor everything, right? And you have some kind of dashboard UI that monitors all of these. Awesome. Pretty simple. But what happens when you have a distributed microservices architecture? A lot of buzzwords in one slide. And basically, you will have service A talking to some kind of database, service B with a cache on top of a database. Both of them are sending information to a queue and communicating with a web server, right? The web server has its own, and both of them are communicating with service C, which is digesting things from the queue, and also running on top of a cache with a database. Wait, of course, you have a distributed system, then you might have some kind of analytics cluster, right? It has a master, slaves. Wait, having said that, you have different teams actually managing that, right? You have team A working on service A, team B working on service B, team C working on the web server and service C, and a whole different department actually working on the analytics cluster with like data analysts, etc. Who's monitoring everything? Okay, whose responsibility is it? It's a really tough question. So let's talk about some basic concepts. We've defined kind of like what we're trying to monitoring and what's monitoring in general. And we have two different kinds of monitoring. We have white box monitoring, which is going into depth into internals, okay? Taking all of the telemetrics and understanding if we have some kind of anomaly in the functionality of the performance system. But we have a different kind of monitoring, which is black box monitoring. I want to know if the behavior of my platform behaves correctly, okay? And if the main workflows that I'm working with, or at least my customers are working with, are behaving well. Everything needs to be shown somewhere, right? So for that, we have dashboards. And of course, what's not actionable, I can't actually do anything with that, even if I have all of the information, so I need alerting on top of it. Amit, can you elaborate more about the other columns?
Sure. So root cause is often, well, as the name implies, what actually causes the problem. For example, not being able to log into the system is a symptom, and the root cause is because all your databases are down. Nodes and machine are, well, what's running your applications. It might be Kubernetes nodes. It might be just simple Linux machine that are running your MongoDBs or whatever DB you're using. Deployment is any change to a service software or its configuration. That means when you release a version, when you change its resources that are allocated. Any configuration change is a deployment. And finally, SLO is a concept taken from Google's SRE, which means it's very similar to SLAs, but instead of being a binding agreement, it's a non-binding agreement, and it's basically what you want to achieve. So you want to have 99% logins successful for reasons that are correct, or you want your database to be up 99% of the time. It's non-binding, but it's something to shoot for.
Yep, totally agree with that. So environment, we're kind of monitoring and handling our own environment, and this is an example of sort of how we're running things. Different kinds of clusters running, of course, of it might be multiple servers, virtual servers, it might be Kubernetes clusters, and all of the environments that we're running on top of it are the different types of environments that we hold the data at. For example, development, testing, live staging, or production. Everything, of course, is being kept in different kinds of data stores, and of course, everything is with different permissions to different environments. On Redis, on Google Cloud Storage, on MongoDB servers, and of course, on top of it, we have multiple services running. Mostly Node.js, but we have different kinds of services also in Python, and we have some kind of orchestration body, which Amit really likes, which is called Jenkins, our brother. So we ended up asking ourselves the question of, we need to put in place some kind of monitoring stack, but what do we actually need to monitor? Okay, and these are the key factors that we want to actually achieve when we basically want to monitor something. We need some kind of metric collections method, right? Or multiple ones. We need to do some kind of data monitoring. We need to put everything in some data store or multiple data stores, present them on dashboards, react with some kind of alerting system. And of course, another like additivity to that is log monitoring systems. So let's begin. Okay, we have some kind of like situation, problems, or examples of infrastructure pieces that we want to like demonstrate the monitoring on top. So let's take an example, okay, from the real world. We have a Spark cluster with multiple workers working with some kind of deployment of MongoDB, which might be also sharded. And of course, for every shard, we have replica sets. You end up with a lot of servers communicating with lots of servers from the other side. We're doing a lot of reads and a lot of writes, okay? So this is one type of use case. Another one might be Cassandra, okay? Another distributed database. And on top of it, of course, it's a big data, fully distributed database, but we need to communicate with different kinds of services with that, right? And we don't want select all queries because it's practically not feasible in Cassandra. We want to get the pinpointed information on big data. So we have a lot of web services and UI clients that access the data and want the single point, okay, and not an aggregate of something. So eventually we end up with multiple problems that Amit will present also.
So when doing big data and when you are increasing your server, your scale, you end up adding more services, more servers for these services, whether it be SQL servers, Redis servers, any kind of server, application servers. You end up having a lot of things you need to both gather your information and analyze it. So just as a small example, from my last workplace, we had an Elasticsearch cluster, which had 2 terabyte a day approximately from HA proxy alone. When you reach that kind of scale, you need the strongest servers you can get, even though Elasticsearch has some limitations, but you really start measuring everything, how much time your instance took, how much time your search took. Sometimes with Logstash, for example, then you had all sorts of regex taking more time and taking CPU from the Elasticsearch cluster. So all these problems are things you need to constantly monitor, to constantly be aware of when you're talking about these big systems.
Yep, and what you eventually do when talking about distributed, this is the DevOps guy. Amit, say hi. And your hair is much better, by the way. And it might be you. It might be the ops guy eventually ending up with handling all of these problems, and it's painful. So let's start with some solutions. Okay, this is what we actually came to talk about. Wait, you want to present the monitoring there on operation systems?
Sure. So, well, usually when you're going to measure infrastructure, you're really looking at simple metrics. Your CPU usage, your memory usage, disk I/O, load average. Load average is actually one of the strongest tools to monitor systems because it's an holistic solution, both to CPU and disk I/O. If you see your load average going to 2 times the amounts of cores, then, well, usually you have a bottleneck either in your CPU or disk I/O. But how do you measure it? Well, you usually use some sort of tool, either collect the stats, the metric bits, report into some kind of DB, whether it be Graphite, Prometheus, Elasticsearch itself, or any other time-based DB. And you also have managed servers such as New Relic, Coralogics, and so on.
Sounds good. Eventually, like we started speaking about monitoring, we started speaking about the infrastructure itself that we're trying to monitor, and a lot of our infrastructure today is on cloud service providers. So let's give some examples from the cloud service, the common cloud service providers that we're using. For example, when using Google, you have a built-in tool called Stackdriver, which is called actually today Google Monitoring, and you have a plug-and-play system that you can actually only click some kind of like tick box and having all of the infrastructure metrics running like immediately to Google's Stackdriver. You can also correlate custom metrics on that. Of course, Amazon has its own solution for that, which is called CloudWatch, which gives you similarly the same thing, having all of the things that Amit has spoken about monitoring infrastructure, about load average, CPU usage, disk I/O, etc., everything out of the box, which is pretty amazing also when you're using Kubernetes or like managed Kubernetes services, and you can output and emit all of the metrics really easily without any configuration because it supports the infrastructure itself. Amit, you want to talk?
Sure. So like I talked about earlier, you need some sort of way to show your data. It's not enough to put them in Graphite or Prometheus. You need to actually show the data somewhere. Grafana is usually the go-to tool nowadays. It's an amazing software, really easy graphics, really easy to create nice-looking dashboards and graphs. And it's a way to both correlate multiple data sources to a single point. So you can correlate your data from Elasticsearch logs to Prometheus or your time-based DB easily in one place. And that's something that is really important when monitoring this data system, because oftentimes you do have a strong correlation between all the things.
Yeah, as you mentioned.
Yeah, and honestly, if you have the money for managed services, it's better to pay. Managing and creating and everything related to big data logs is often painful, especially with Elasticsearch, for example. A lot of things are painful there in index management and template management. There are services that cost money, but do solve all the issues, whether it be Coralogics, Datadog, Logs.io, there are hundreds. But once you just say, I'm willing to pay the money to save my people's time, your DevOps time, usually.
The most precious time.
So, exactly. It's something that it's time wasted because you can just pay and save it for something else that is much more important, or not more important, but that you cannot outsource.
Totally agree with that. And again, think of it that you're throwing the problem of big data, generally the monitoring of big data, to somebody else, which is pretty nice. Okay, connections, right? We're connecting to a lot of multiple data sources. How do we monitor that, Amit?
Well, usually when you write applications to SQL, MongoDB stuff, then you usually have your usual actions, you have your selects, inserts, updates, and so on. And you usually want to monitor how much inserts you have, how much data they entered. Do you have updates in big data systems? It's actually critical to monitor your updates and deletes because they're usually not good at that, so you don't want it to happen. You can do multiple things. You can create wrappers, so whenever somebody sends an SQL query, just write it to either a DB or somewhere else that you can later analyze and see how much time they overall took, how many of them happened, and so on and so on. Essentially, the more raw data you have about your actions, the better. You can also write it to log and then analyze later in Elasticsearch, but at the end, you do want to monitor this stuff.
Sure, I totally agree with that. It's a really hard pain point of actually having monitoring only on infrastructure without understanding how your users actually using that. So combining everything is amazing. Cassandra, okay, we spoke about the database, a cool database, War Veteran, I would say, which a lot of companies actually use. But how do you do that? Okay, and you can read the examples of actually how it is to monitor and which are the pain points of monitoring distributed databases in different kinds of blog posts that I have here in the links, and we can share also the presentations afterwards. But think of it that one of the biggest pain points, because you're handling the cluster and they're all hopefully homogeneous servers, you need to kind of identify them and know where the bottlenecks are. Okay, and if one node is misbehaving out of a cluster of 100 servers, it's pretty hard to actually identify that if you don't have proper monitoring. So with Cassandra, you have multiple, it's running basically on a JVM. So for that, you have plug and play metrics with Graphite that you can actually input some kind of a plugin to that and report back to the tools that Amit has mentioned. Okay, so for example, if we spoke about Graphite and maybe even Prometheus and different kinds of data syncs, you can streamline all of the inner metrics of Cassandra to it. And of course, when you want to do a drill down on a specific node that is misbehaving, you can go to the regular tools of dstat, iostat, iotop, and JStack, etc., to kind of like understand what is happening on a single, on a scope of a single node. Of course, you have different kinds of architectures of reporting back, right? And for example, the company that supports heavily in Cassandra data stacks has its own internal tools also to kind of like give transparency to your infrastructure and the ops center itself. And of course, on top of it, you can also streamline all the metrics to a different sync, as Amit has mentioned, like InfluxDB, Graphite, even maybe Prometheus, and show everything on Grafana dashboards. And of course, you can sometimes even plug that into the regular cloud service provider monitoring tools. Of course, we're speaking about big data, right? Should we actually do with our data? Should it be monitored too? As we mentioned in the pyramid in the beginning, yeah. So you need to go in the world of data questions, okay? And what you actually should measure. So first of all, if you're a compute-intensive platform, did all of the computation actually occur, okay? And are there any data layers actually missing? For example, if we're working on the time series basis, did I enter all of the relevant information of this specific day? And of course, asking how much volume do I have in the data store itself? Practically on every cloud service provider, you're paying as you go, right? So you need to know how much data you're actually ingesting and how much data you're saving. I mean, also we have the dispute with Amit about like compressed data and uncompressed data. And how do you actually save all of that? And with what kind of granularity, of course, because maybe I don't want all of the most relevant data of the last 30 days compressed, but it costs a lot, right? And everything goes down to money. Amit likes the money. And of course, is everything actually exists in the database, okay? It was really easy to actually check if you had a single server, right? You just do select star on something and basically get the amount of rows that you have. But what happens when this query is so expensive, you need to actually invest 100 servers that ask that question and return back in a reasonable time. Then basically you need to create some kind of mechanism to maybe incrementally do that, to ask that question and answer it really fast. So my friend actually kind of like defined the world problem to DQA, data quality assurance, which is really important. It's not a real profession, okay, but it's something that actually we need to do when we're handling big data systems.
So one thing we did at my previous job, we had a process that synced data from two SQL clusters. We didn't want to make an expensive tool, something that will take us a lot of time. We really wanted to check the validity of the data as fast as possible. So we did a simple thing. We created a small Python script that just selected counts of several event types from both databases and compared them. Afterwards, we had both Jenkins reporting on whether or not the data counts were correct. And we also had the results stored in a simple SQL table that we could query back in history to see the variance in sinks. If we had sometimes sinks going lower, going higher, we could query it afterwards to see what were the reasons.
And yeah, you want to cover that or you want me to cover it?
Go ahead.
Okay, awesome. So basically, as Amit has mentioned, it does as long as you know which questions you actually want to answer, and you need to actually implement some kind of solution in place. Okay, you need to follow the results over time, know your data flow, and know what actually might fail. And of course, it should be really, really easy for every developer or every piece of the puzzle basically working in a company to add some monitoring. For example, at Panoramic, we have people from marketing department, customer success team, and even sales coming to Amit and asking for different kinds of metrics. Amit, you can maybe even like elaborate some more about the integration and tools that you've kind of combined to our monitoring system.
Sure. So at Panoramic, originally we had a problem where a lot of our operational data was in MongoDB. Grafana doesn't have a built-in connector to MongoDB, and it can be hard to query it also. So a thing I did is I wrote a simple ETL script to get the data out and into SQL, and created a Grafana, and then started adding dashboards. And over time, people not only requested more and more data, but they also started adding more graphs and asked. And once the data they could ask the data questions, they started doing it, and more requests came, whether it be integration with Salesforce and other platforms to sync the data from our databases and Salesforce and vice versa.
Yep, sure. And of course, don't trust others to actually add monitoring, okay? It's not, okay, right now I've developed my code, awesome, I've deployed it to production, and right now it's a DevOps fault, okay? No, monitoring should be applied to all, okay? Should be applied to all of the people, and even if they don't know how to actually implement that they have a problem of streaming the telemetrics, consult with somebody, okay? Somebody will help you at a company that knows infrastructure, some amazing guy like Amit. Okay, so we ended up with another piece of the puzzle, right? Logging. And how do you monitoring with logging? Amit.
So there are a lot of solutions today. The main solutions for monitoring loggings are usually based on Elasticsearch or something similar. One managed service that we like is CloudWatch. It's a managed Elasticsearch that helps you with anomaly detection and incidents, which is usually pretty important because it's hard to make sense of the amount of logs you have usually. But when you have a solution that just identifies those anomalies for you, for example, you had a high error rate, more than usual, or these logs came in a way that they don't usually do, then it helps you find errors that you might miss when you analyze it manually.
Yeah, all the anomalies and basically surfacing might even as a human being, and with machine learning and different kinds of algorithms, basically popping it up to you without you putting any effort.
Right. So as I said, Elasticsearch is at least my go-to tool for monitoring. It is an open source tool. Today, the stack is comprised of Elasticsearch, which is the DB based on Lucene, Bits or Logstash, which is used to ship and index logs. Bits is the preferred way of doing things today. It's a lightweight Go-based log shipper. Logstash is a heavier JVM-based logs indexer that has more features than Bits, but is often heavier and causes a lot more issues. And Kibana is the UI for all of this. You can search logs, you can create visualizations, and also connect Elasticsearch to Grafana to have a place to question, like I said, all your databases.
And another example of different kinds of dashboard, of course, Elasticsearch, Logstash, and Kibana. And it's always cool to see a map and some flaming graphs, which is also impressive without saying anything. And dashboards. So we spoke about dashboards, and a lot of times we have multiple data sources that we want to show on a single dashboard with different kinds of queries. It doesn't have to be some kind of login metric system that connects to Elasticsearch, and it doesn't have to be also some kind of time series database in which we need to show trends. Sometimes I really want to query something and only show a number. But what happens when you want to correlate everything and even create your own kinds of databases which are not supported by the regular tools? So we have Redash. Okay, Redash is an open source tool that was created by a company called Everything.me that doesn't exist anymore. But Arik, the great guy that you see in the photo, is actually the maintainer of Redash. And right now he has created also Redash as a service. So we're doing a lot of monitoring and a lot of types of things. And you can create it like an integration with a tool like Redash to actually show that on a single dashboard and create a connection to MongoDB, to Cassandra, to different kinds of databases. And if you're a database lawyer and you want to create a plugin and basically having an integration with Redash, it's pretty simple to write that in Python with your regular API and have that as a part of the platform itself. And it's amazing. There's some screenshots, of course, showing a map, showing some flame graphs, like everything. Amit, do you want to elaborate more about our dashboard?
So like I said earlier, we created some dashboards on the data itself. Now, it's important to note that this is not necessarily metric data. This is all either analytics created on top of the data that already existed. It wasn't created especially for that. But once you write the data to your databases, you can usually also question it. So either it be some cumulative metrics of how many companies we added over time, or connections or logins. All of these things were already in the system, but once we exported them to queryable databases, you can actually ask your questions and show them in the graphs. And these are kind of the things that give you the most value you can get from your system, because at the end of the day, that's what's important for the business. It doesn't matter if your databases are at 80% CPU constantly. It doesn't really interest anyone. But if you say, right, so my logins are slow, and then you see your CPU at 100%, then right, it might interest someone.
Yeah, and it's really critical to actually go to that immediately. And of course, something should be actionable. For example, we have different kinds of tools. Today we have integrations to Slack and other things that we can integrate with our cloud platform and with internal services. Even Grafana has plugins to different kinds of things. But an example of a tool that we use on top of Graphite in my previous company was Siren. It's an open source tool that has integrations to multiple things, and basically you can track events and things about alerts and send it off to different kinds of places. So this is another, again, we need some kind of alerting system. This is another way of creating that integration. So what we ended up with, okay, we have different kinds of, we started off with a regular monitoring stack that we wanted to answer with tooling. So basically we've created this kind of tooling, right? Collect D and stat D for metric collections. And a lot of times you have integrated plugins with a checkbox you can tick and basically shift all of the telemetrics of your cloud service provider to some kind of data store. We spoke about data monitoring that you can really simply make with Jenkins queries. For example, Jenkins schedule jobs that do queries with some kind of SDK and put that inside of a data store. And of course, data stores of different kinds, Graphite, InfluxDB, even Prometheus, and different kinds of Elasticsearch things. Of course, we need to show everything with some kind of dashboard, right? So we have Grafana, Redash, New Relic, CloudWatch, Stackdriver, all sorts of dashboards that you can create if you want to correlate everything on different kinds of dashboards for different things. Sometimes even you're using an external tool and they have their own dashboard without any integration. For example, some managed database service providers. And of course, I need to show logging, right? So some of the things in the matter of dashboard, you can correlate that to CorelLogic or any other like logging tool that I'm using. And of course, alerts. We can put alerts also on CorelLogic, Console, Grafana, on internal tools, and send the telemetrics and everything to Slack, Slack channels, emails. We literally have everything, okay? And eventually you end up with alerting noise. So aggregation and actually alerting on things that you can actually respond to is really important. If you have an alert that says restart, okay, and this is the solution, create an automatic script that does the restart and eventually aggregates something daily and says how many times it did the restart, or some kind of ruling mechanism that says if it had restarted 10 times maybe, then send me some kind of alert and don't send me any more alerts because I can't do anything with that. Something really, really important that developers always like to do, okay, blame other people. Work fine in dev, ops problem now is a big no-no, okay? It's not only my problem. If I develop the code, I want to have transparency on what's going on with the code itself and then respond to that. And the responsibility is mine. The DevOps and the ops people can help me. But again, I need to have the basic measurements to actually have transparency on what's going on with my code in production. So who does the monitoring? Everybody does the monitoring. Everybody in the company, as we mentioned, even the salespeople, the customer success team, the marketing people, everybody wants to know what's going on with the production environment. If it's user metrics, if it's infrastructure metrics, if it's all combined to kind of create a load average of the platform, it's super important. So conclusions, okay? Correlated application and system metrics is super, super important, okay? Because once we know that, it can help get to the root causes of all of the problems that we have in our infrastructure. I don't know if the CPU is spiking to 100%, why it's happening, if I can't correlate it to other metadata. Ask the right monitoring questions and answer them with dashboards and relevant alerting, which is really, really important. Don't alert on something that you can respond to. Keep it simple, the KISS standards, okay? It's hard. And again, what is hard, basically we don't do, okay? Because the strongest feature with developers and software engineers in general is that they're lazy, okay? A lot of things are being done and a lot of tools in the world have been created because people were lazy. And it gave great outcomes. So keep it simple and basically answer the right question. And of course, measure whatever you can. I always joke about it that the storage is cheap. We eventually ended up that storage is not that cheap when you're handling big data, but still measure whatever you can and save the information, because if you haven't saved it, it's gone. But erasing that might be feasible, okay? And of course, the really important thing is to monitor your business KPIs too, because all of the effort that we're putting in as engineers, when you want to justify that to your management platform, okay, all of the C levels and D levels that make the decisions, you easily can pull out the relevant number that you need to actually like acquire, or the amount of money that you need to enhance your platform to support your users. Why? Because you have monitoring on that. You have all of the metrics, and basically you need to end up with some kind of number. If I haven't convinced you with all of these kind of things and all of them, it's great explanations that monitoring is important, okay, I don't care, because this is my face basically when I'm looking at monotonic graphs that go on and on over time, because graphs are fucking cool. Yes. I actually didn't see any questions that were written in the chat, but I would, okay, I would enter the relevant question because we practically spoke really, really fast for 45 minutes, and probably most of your faces are like, what? Amit, what is the most fun thing in monitoring in general when you have on a day-to-day basis?
Well, I think the best thing is seeing graphs go down that are supposed to go down. But for example, if you have graphs of average query times or average query run times, and they suddenly go down by half, that's an amazing feeling.
Yeah, totally.
And it's often nice to have your, for example, you monitor how much data you have in your system and see that go over time with several spikes that you can correlate to real world events. For example, we had a successful campaign at that period and suddenly our data shot up. That's really good to know. You can also pass it on to your sales or marketing team that, hey, this campaign worked really well. Keep doing that. And you can do that really fast. You don't have to wait a few days anymore to get that information back. You can see it in real time, even with systems like Elasticsearch and so on.
Yep, that's pretty amazing. Even like for me, I would call myself like management in general. When you see correlation between different kinds of things in the company, which are not only code, okay, or not only services, and you provide value to all of the other departments in the company with only like showing the data, which is really, really hard when you're handling a lot of data. Okay,
yeah, and
so
no, go on.
Yeah, I mean, go ahead.
Yeah, I just want to say that you also often get good feedback about it. If you want to impress people at your job, then just create graphs, because the graphs and so on and monitoring in general is something that everyone can look at. It's not code, it's not obscure metric somewhere with Zabbix or whatever. It's something really approachable, and everyone knows what a graph is, what a line going up or down. So doing that is also not only a way to impress your coworkers, but a way to improve your work, because oftentimes you go to a problem and ask yourself, okay, where is the problem? You open up your dashboards and visually you can see usually quickly where the problem is if your graphs are good, and that's time saved, that's headache saved. Visualization is a really powerful tool because we are visual entities. So so as much as you can visualize stuff, the easier your job will be.
Yep, I totally agree with that. So we ended up right now in the end of the webinar itself. I would like to thank everybody that joined the webinar itself. Thank you for Codemotion and Demi for facilitating. And keep on joining our webinars. And if you'd like to hear more about Panoramic and about other things that we're doing in the company in the matter of tech, infrastructure, etc., you can search us on Google also, and you can contact Amit or myself on Twitter and social media. If we can help with anything and maybe share from our experience, we would love that. And thank you very much for joining. Bye-bye.
Thank you very much. Bye-bye.